These very important vessels supply the blood with brain, are critical for brain function. We're going to start with blood coming up through the foramen magnum via the vertebral arteries. They're so named because they run up alongside the cervical vertebrae. They actually go through little holes in the sides of the vertebrae. So the vertebral arteries, you got one on the right, one on the left. They come together, they converge to form a single midline artery called the basilar artery, which you can refer to by its eponymous name, the Tim-Basilar artery. You should call it that at UCSD. That's what everyone calls it. That splits into two posterior cerebral arteries, one to the right, one to the left. And they have little branches that connect to a major arterial supply that's forward of where we're looking right now. So we came from below up through the foramen magnum, through the vertebral arteries, basilar, posterior cerebral. These are tiny little connecting arteries called posterior communicating, and they connect us to the internal carotid arteries. Now those are drawn as circles here. I want you to imagine that you're looking at the brain kind of from below. The internal carotids are rising straight up toward the brain like that. And the vertebral arteries came from sort of posterior and a little lower. So this is like a cross section through the internal carotid artery at the very top of it, where it's ending basically, because it branches terminally into anterior cerebral arteries, left and right, and middle cerebral arteries that shoot out to the side. So we basically have three sets of cerebral arteries, anterior and middle. They come off the internal carotids, and the posterior cerebral arteries arise from the basilar. And then these little communicating arteries, these posterior communicating arteries, connect the two supplies from the internal carotid and the vertebral. There's also an anterior communicating artery connecting the two anterior cerebrals right there. So the entire system here is one where we have four major arteries, four big arteries supplying the brain. There's two vertebrals and two internal carotids. And each one of these arteries is connected to the other through this system. There are arterial anastomoses here connecting them all. And in fact, you can see there's a continuous ring of arterial supply here. And we have a name for it. It's called the cerebral arterial circle, or circle of Willis is the eponymous term. And so it is possible for you to get from anywhere in this circle to any other part of the circle, right? Regardless of which artery you came in via. Another way of putting this is that you could gradually, don't do it all of a sudden, you could gradually occlude 3 out of 4 of these arteries. And as long as you occlude just those, the last remaining one that was unoccluded could theoretically supply the entire brain by going through all these branches, right? By the interconnections provided by the cerebral arterial circle. Yeah. Still not a good idea to occlude 3 out of 4 of those arteries, but the point of that is there's a very redundant blood supply to the brain. Okay. Also, I want to mention that the cerebral arterial circle surrounds. I've drawn it, larger than life here. It's pretty diminutive in size, but it encircles some really critical structures and major landmarks at the base of the brain. One of them is the optic chiasm. Chiasm means X. That's where the optic nerves meet and then cross. And then right behind that is the stalk of the pituitary gland, which is a bold term for this lecture for this reason, and is going to come up for sure when Tim discusses endocrine function. So that's the cerebral arterial supply. I want you to understand, I want you to relate these major arteries to major targets that they supply. So the anterior cerebral artery is supplying, among other things, the part of cortex, kind of a strip in the middle involving, there's 2 anterior cerebral arteries, one right, one left, and they supply a medial strip of cerebral hemisphere that includes parts of both of the primary somatosensory cortex in parietal lobe and primary motor cortex in frontal lobe. And so if you have a problem with the anterior cerebral artery, it can affect either or both of those regions, and you can get loss of sensation due to ischemia or necrosis at the primary somatosensory cortex. You can get weakness or paralysis if you damage the primary motor cortex due to, say, an occlusion of the anterior cerebral artery. If you block one of the middle cerebral arteries, that could disrupt memory and learning structures and lead to amnesia and difficulty learning. If you disrupt or occlude a posterior cerebral artery, among other things, those supply the occipital lobe, and so you can have problems with vision because the occipital lobe, the posterior cerebral artery is supplying the primary visual cortex and occipital lobe. And finally, the basilar artery there's a lot of overlap between these, but the basilar artery, among other things, supplies the brainstem and cerebellum. If you damage the brainstem, you get stupor, lethargy, stupor, coma, and then death in increasing order of severity. If you damage the cerebellum, you get ataxia, which is a clinical term for just clumsiness and lack of coordination. So the cerebellum, for example, is lesioned with excessive intake of alcohol, which is why if somebody's drunk, they kind of stumble and they lose their coordination. That's a lesion. That's a temporary lesion of the cerebellum. So I hear.